everyone. We are honored to have this chance to introduce our project. It is called Multifunction NC Mediation Injection Machine. We students in vocational high school learn to operate the machine and get our hands on the machine so that we can sharpen the skill while putting knowledge into practice. Unfortunately, when it comes to process related to the molding injection machine, we can only learn the form of the machine through the textbooks. Many schools do not purchase the machine because it is expensive and it costs too much space. For students who are curious and always eager to obtain more real experiences, however, this is not good enough. It occurred to us that maybe we can make one by ourselves. Being high school students, we have limited budget and resources. How can we make one that more people can afford and can be easily moved around without taking up too much space? The first question that comes to mind is, what we can do the molding injection machine with? With prevalence of 3D printer, we talk about the possibility of using 3D printer. Since we have experience on assembling and modifying 3D printer, we decided to design a micro injection machine with 3D printer on our own. As for software needed, we find that open source software Mali may be a good choice to help us control motor and switches with NC code. Still, how can we do it? As you will see in our presentation, we not only have to go through lots of experiments with the hardware and the software, but we have to overcome the challenge of manufacturing a micro injection machine by using a variable lead screw, which features simultaneous delivery, pressurization, and extrusion. We transform the solid material into liquid form and reduce production of bubbles, while reducing design complexity of hydraulic components and lowering costs.
The following is our design and production process. First, we design a component of micro molding injection machine. Then, we start to make injection unit.
In order to make our injection machine automated, as you can see from 4 to 8 here, we make one machine component like a clamp and auxiliary module. Before using a motherboard or 3D printer to control our injection molding machine and writing the code, serving as interface can help us control motor and operation.
Now, we're going to the experiment process. After the completion of micro injection machine, we start to perform several experiments on our injection moldings.
In the first experiment, we find that the changing temperature has a great influence on finished product. So we decided to do a PID temperature control experiment first. At the end of the experiment, we find that the Kp value is close to the target temperature when it is about twice the reading on the code of M303. Also, the larger the Ki value is, the larger the amplitude is. The final adjusted Kd value is found to reach state of stability within shortest period of time when it runs at about 1.5 times. So we decided to use following parameters: Kp 7.55, Ki 0.05, and Kb 585.36 for following experiments. Since the micro injection machine mostly to make PP, we choose PP with a good property as a target material in second experiments. After meeting the needs of keeping the temperature stable, we are able to find out the relation between the temperature and injection volume. At the end of this experiment, we choose 200 to 210 degrees as the most suitable temperature for PP material.
After getting the right temperature, in our third experiment, we made a continuous shot and try to shorten the shot time. But when the extrusion speed is increased, it will also affect the injection volume. Also, when the stepper motor's rotation speed increases, the torque will decrease at the same time, which has profound impact on our experiment. After this experiment, we find that the injection volume is more stable when the parameter M is 300 to 400.
To respond to different sizes and understand the injection stability of variable lead screw, in the fourth experiment, we experiment with actual value and the amount of injection. The weight of extruded polypropylene is measured by adjusting the set value of of extrusion above E. At the end, we set output parameter F at 200 and temperature at 200 as a fixed value. As you can see from graph, the parameter E also changes linearly when it reaches 700, with a volume of current master model being theoretical maximum cavity space. We stop experiments. At the end of this experiment, we are able to prove that the injection stability of the screw can be used for mass production and help us to have a reference for the amount of extrusion when changing mode in the future.
In conclusion, there are few features in our project. We have made our injection molding out of different materials. The first is our PP, which is the materials most widely used in industry. The second material is our PLA plastic, which is environmentally friendly. Moreover, the NC code in 3D printing control panel can facilitate the multiplication of various parameters and serves the function similar to that of industrial PLC, which is most widely used in manufacturing controller.
Also, in terms of teaching tool, this injection machine can help students operate injection molding machine and understand how it works, getting hands-on experience. What makes our machine truly stand out is multiple controlling ways. That is, we can run on the parameter for automation with some adjustments on the cell phone. Moreover, with the Wi-Fi access, we can put whole machine into a humidity control box without having to worry about the problem caused by moisture absorption. Last but not least, this injection machine not only has the advantage of low cost and user-friendly operation mechanism, but it can only be operated with 110 V power supply as well. It means that you no longer have to use air pressure or liquid pressure. Wherever you go, you just plug in, or with the help of transformer, you will be able to use it. How convenient it is, isn't it? Thank you for listening.